A milk chocolate bar is packaged in a box shaped like a triangular prism. The two bases are congruent equilateral triangles and the three faces are congruent rectangles. This bar is available in 1 and 2300 ounces, 2 and 4600 ounces, 3 and 6900 ounces, and 4 and 9200 ounces sizes. Using the values in the table, write a function for the length of the boxes, the area of the triangular base, and the volume of the boxes. If the chocolatier plans to put a new 11 and 700 ounce bar on the market, what would be the volume of the packaging box if the triangle side length is 9 inches? Okay, so you might get a little bit confused with all these different numbers. They give us the bar size, and then they also give us the triangle side length, 0 through 4, the box length, the area of the base, and the volume. And we're trying to find functions for L of S, the box length, A of S, the area of the base, and V of S, the volume. And notice that the input for each of these is S. And so bar size, it just kind of tells us here, but really our input is S. And so notice that our delta S just goes up by 1 every time. So that's going to be important. And then we need to find the functions for L of S, A of S, and V of S. And also note that the volume of a triangular prism is equal to the area of its base times the height of the prism, or in this case, the length. And so we just know that V of S will be equal to L of S times A of S multiplied together. And so let's use finite differences to find L of S and A of S. So finding the first differences of both of these, then for L of S, then subtracting in order, starting from the bottom, going to the top, we get 4 and 2/10, a common first difference. And so this will be a linear function. And so we notice also on A of S, we did not get a common first difference. And so we will have to actually find the second difference. Let's go ahead and do that. So when we subtract from the bottom to the top each pair, then we do get 866 thousandths, and so this will be a quadratic. So let's first find L of S, and we know L of S will equal M, and then instead of X, we'll put S here, plus B, and so to find M will just be the rate of change, delta Y over delta X, in our case, delta L of S, or in other words, 4 and 2/10 divided by delta S. And remember that we saw in the table there, that that was 1. So those divided together just give us 4 and 2/10 S. And then B is our y-intercept. And in our table, then S was 0 on the first row, 1, and it just went up by 1. And so when S equals 0, then L of S equals 0. And so B will just equal 0. And so we don't have to put anything on the end there. And so L of S will equal 4 and 2/10 S. And then for A of S, then we have our second difference that's the same. And so we know that 2A will equal the second difference, which is 866 thousandths. And so dividing by 2 on each side, we get 433 thousandths. And then to get B, then A plus B equals the first difference between 0 and 1, which would be 433 thousandths. And then substituting A, then we see 433 thousandths plus B equals 433 thousandths. Well, we know then that B must equal 0 to make this equation work, because subtracting 430 thousandths from each side, then that would just equal 0. And then our y-intercept, C, well, again, the first row, if S is 0, A of S is 0 here. So C is 0. And so using that information, then we know that A of S will equal 433 thousandths S squared. And then since C and B are 0, then that's going to be it. Now to find V of S, we just need to multiply those two things together. So I'm just going to fill in for L of S and A of S. So multiplying those together, 4 and 2/10 times 433 thousandths equals 1 and 8,186 10,000ths, and then S times S squared is S cubed. Our final step is finding for an 11 and 700 ounce bar. And remember that the number of ounces doesn't really fit in our equation anywhere, but we do know that the side length is S in our equation. And so here it tells us the side length is 9. And so we can plug in 9 for S, and then we're trying to find the volume, so we can just use our V of S equation. So V of 9. So putting this all into a calculator, then we get 1,325 and 76 hundredths inches cubed, since it's volume in inches. Now that we have all of the pieces, then we can go ahead and summarize our answer. The length function is linear. L of S equals 4 and 2/10 S. The area of the triangular base is a quadratic function. A of S equals 433 thousandths S squared. The volume function is a cubic function, the product of the area of the base and the length. V of s equals A of s times L of s equals 433 thousandths s squared times 4 and 2 tenths s equals 1 and 8,186 10,000ths s cubed. V of 9 equals 1 and 8,186 10,000ths 9 cubed equals 1,325 and 76 hundredths inches cubed.